Good morning, everyone. My name is Matt Widener. I'm a cyber engineer and analyst with Red Sky Alliance, and I'd like to welcome everyone to our very first Red Short webinar. Red as in something important from Red Sky Alliance, and short as in once a week for 10 minutes or less. Today's webinar, we're going to review the Ragnar Locker ransomware, and we've provided a detailed report via the link on your screen there, and we'll also put that in the chat box. Ragnar Locker is a fairly new ransomware strain affecting Microsoft Windows devices. It was first seen in the wild in December 2019, affecting several undisclosed corporate networks. Initially, the ransom demands were Bitcoin amounts in the range of $200,000 to $600,000 US. However, those amounts quickly escalated as larger enterprise organizations were compromised. In April, Ragnar Locker attackers demanded a ransom somewhere in the range of 10 to 15 million US dollars from the multinational energy company EDP. And then in July, CWT, a business travel management service company, paid a ransom in the amount of 4.5 million after negotiating the amount down from 10 million. With that payment, the company hopes the attackers will keep their word and choose to refrain from releasing stolen data that was taken during the attack. And also, they're hoping that they will provide decryption keys to restore all of their encrypted data. And lastly, in September, two Asia Pacific subsidiaries of the French shipping company CMA CGM were infected with Ragnar Locker, forcing them to disconnect their worldwide booking and documentation processing infrastructure. They've since cleaned that up and reconnected that infrastructure. The ransom amount has not been disclosed, but from historical patterns, we estimate it to be between $10 million and $20 million US. Some of the key capabilities of Ragnar Locker include some that initially made it unique among ransomware strains. For example, one way that Ragnar Locker hides itself from detection is by installing a stripped down version of the VirtualBox hypervisor and running the encryptor payload inside that virtual machine. The host OS and its security tools do not have visibility inside the VM and thus are unable to detect the running malicious payload. To access files on the host system, the malware uses a feature of VirtualBox called shared folders. And once that's configured, the malware is able to access the host device's disk drives from inside the VM, including any mapped network drives. And through the shared folders feature, the malware scans for data files to encrypt. This method of hiding itself has been effective enough to influence the Maze malware group to implement it in their own ransomware. Ragnar Locker also avoids encrypting data on systems whose Windows locale matches the list at the bottom of the slide, including Russia, Ukraine, and many Central Asian and Eastern European locales, perhaps hinting at a rough attribution for the malware's authors. Ragnar Locker avoids encrypting operating system and application program files, which would cripple the device. And this is important because the attackers want their decryptor to be able to run on an infected device in the case that the victim actually pays the ransom. It also deletes file system shadow copies, which could be used to restore the unencrypted data without an attacker-supplied decryptor program. It also actively seeks out third-party software used by managed service providers for remote administration and disables them. It also disables certain Windows OS services and applications that would lock data files and prevent encryption or allow for restoration of unencrypted data, like backup processes and the aforementioned shadow copy service. This is most likely done to prolong the amount of time it takes for MSP administrators to detect the intrusion by preventing them from accessing the device. For encryption, Ragnar Locker generates a unique encryption key and a salt value for each file. The file is then encrypted with the SALSA 20 algorithm. And then the SALSA 20 key and salt values are concatenated together and encrypted separately with RSA using an attacker-supplied public key. And that encrypted key is attached to the file. This method clearly shows that cryptographically, it's technically feasible for the attackers to supply a decryptor program if the ransom is paid. This is important because some ransomware, like NotPetya, either due to programmer error or design, do not properly handle the encryption keys in a way that makes decryption possible. Ragnar Locker doesn't have an automated propagation mechanism. It is manually launched by the attackers after a network is compromised. And according to the limited amount of information we can find in open sources, attackers will initially compromise an organization by exploiting public-facing RDP services and possibly those MSP remote administration tools that we mentioned earlier. They'll exploit those to gain an initial foothold. Then the attackers will move laterally through the network using native Windows administration tools like group policy objects, MSI exec, or PowerShell. And during that lateral movement phase, sensitive data files are identified and then downloaded by the attackers. That information is then held for ransom under threat of public release. After that data is stolen, a dropper is then manually uploaded to the victim network and executed by the attackers. And that's the piece that installs the VirtualBox hypervisor and the VM for the malware to run the encryptor payload. The malware that's in the VM then scans for data files to encrypt. And then once all the files are encrypted, a ransom note is dropped on the host device. It's interesting to note that the Ragnar Locker dropper does not have any privilege escalation measures built in, despite the fact that it requires system-level access to perform some of its functions. And this shows that the tool is not meant for broad automated distribution, but rather reserved for targeting specific organizations. So as far as detection and mitigation goes, specifically for Ragnar Locker, it would be good to monitor file systems for VirtualBox related files that should not be running on machines that should not be running VirtualBox. Also, the .ragnar_star file extension is appended to any encrypted data files. That would be an indicator of compromise as well. There are some file hash indicators publicly available, but because Ragnar Locker is used to attack specific target networks, and each dropper is configured specifically for the target network in regards to the ransom note, it's not likely that new victims will see old samples being used. Consider deploying a ransomware honeypot with decoy data files. Any change to those data files could be used as an early warning indicator for a ransomware attack, not just Ragnar Locker, but any type of ransomware attack. A good backup strategy is essential for surviving any malware attack, and having the ability to restore your data from a known good backup is the best way to avoid even having to consider paying a ransom. Practice the principle of least privilege when configuring network file shares. Configure user or host level access permissions and read-only access when possible. And of course, keep your antivirus and OS patches up to date. Thanks for joining us. If you have any questions regarding the topic brief today, please get in touch with Jay McKee at wapaklabs.com. Thanks again, and please join us on October 14th for our next Red Short.